Hi friends, in this video I am going to explain about the how to draw the frequency characteristics. Clear? So in the last class or in the last video I explained about the relation between the time and frequency relationship. Yes or no? So now when we are discussing about that particular relation between the time and the frequency response analysis concept. So in the last we got the equation, that is C of t is equal to 1 divided by under root 1 minus u square whole square plus 2 zeta u whole square into sine of omega t minus tan inverse of 2 zeta u divided by 1 minus u square. Okay, so this is the output, steady state output equation we got in the when we are discussing about the relation between the time and the frequency response analysis topic. Clear? So now with the help of this output equation I am going to draw the frequency characteristics or frequency characteristics in the frequency analysis. Clear? So here how to draw the magnitude characteristics and how to draw the phase angle characteristics with the help of this equation means, so simply, so in this equation the term u is equal to omega by omega n. It means instead of omega divided by omega n we are substituted the term u. It means now in this equation we are going to vary the value of u, then you will get the different value of magnitude and the different value of phase angles. Clear? For example, just see here, so this is the total, so this part is completely magnitude, and this total value, this total tan inverse of 2 zeta u divided by 1 minus u square is the phase angle. Clear? So when we are talking when we are going to vary the values of u, so then you will get different value of magnitude and different value of phase angle. Clear? So for example, I am going to place the value of u is equal to 0, then by solving that equation definitely you will get the value of m is equal to 1 and the phase angle phi is equal to 0 degrees. So these two values under when u is equal to 0. For example, if u is equal to 1, substitute, then m is equal to, definitely you will get m is equal to 1 divided by 2 zeta. Clear? And here phi is equal to minus 90 degrees you will get. Clear? So like that, if u is equal to infinity, then m is equal to 0 and phi is equal to minus 180 degrees. It means by varying the value of u, where u is equal to omega by omega n, then you will get the different magnitudes and the different phase angles. Now with the help of all these different values of magnitudes and different values of phase angles, you can draw the magnitude characteristics and phase angle characteristics. Clear? So just to see here, so this characteristic related with the magnitude and this is related with the phase angle. Clear? So already we know that the value of m is equal to 1 and m is equal to 1 by 2 and m is equal to 0. That's why what I am doing here, so I am starting with the 0 value. So I am taking the values 0 0.2, 0 0.4, 0 0.6, 0 0.8, 1 and 1.2, 1.4, like that I am taking. And here the value of u. So here already we know the values, different values of u and different values of magnitudes. Clear? So just see here, for example, when u is equal to 0, it means, so this is 0 for example, and this is, for example, assume this is 1, for example u is equal to 1 this point, and when u is equal to infinity, for example here. Okay, so then how to draw the magnitude characteristic with the help of the different values of u. So u is equal to 0, m is equal to 1. It means when u is equal to 0, m is always 1. Clear? It means the characteristic is always starts from this point, because at u is equal to 0 condition the value of m is equal to 1. Clear? Next, when u is equal to 1, the value of m is equal to 1 by 2 zeta. Clear? So it means when u is equal to 1, then the value of this point m is equal to 1 by 2. So actually 1 by 2 means 0.5. So with the help of this value zeta, there is some small change. For example, assume 0.7, 0.707 or 0.6 or 0.8. Okay, so definitely because of the zeta, definitely you will get some there is some change in the value. Clear? So that's why what I am doing here, so I am taking the value of when u is equal to 1 condition, I am taking, for example, that one is 0. For example 0.8 0.81, for example I am taking. Okay, so here when u is equal to 0 condition, m is equal to 1. When u is equal to 1 condition, m is equal to some 1 by 2. With the help of zeta, I am just taking 0.8, no problem. Okay, and here when u is equal to infinity, m is equal to 0. It means, so when u is equal to infinity, it means this is the curve. So we don't know exactly, but I am just taking when like this, clear. So this is the u axis, that's why. So when the value of u is infinity, then definitely this curve will reach us exactly 0, clear. So this is the magnitude characteristics when the different values of u varies, clear. And that is clear. Okay, then u is equal to 0, then phi phase angle phi is equal to 0. It means when u is equal to 0 condition, phi is equal to 0 degrees means, so this is related to phase angle. That's why when u is equal to 0, so angle phi is equal to 0 degrees, clear. So what I am taking here, 0, minus 90, minus 180, because the values are always minus 90 degrees, minus 180 degrees. So no need to go for the positive angles, clear. For example, if you are getting the positive angles, then you can draw positive angles, clear. So when u is equal to 0, phi is equal to 0 degrees means when u is equal to 0, phi is equal to 0 degrees. It means the characteristic will start from 0. And here when u is equal to 1, phi is equal to minus 90. It means when u is equal to 1, here when u is equal to 1, so definitely the value of phi is minus 90. That's why the curve is directly decreases to this point, clear. And when u is equal to infinity, then phi is equal to 180. That's why, so when u is equal to infinity condition, we don't know exactly, but when u is equal to infinity condition, or at the time of u is equal to infinity, definitely this curve will reach us to 180 minus 180 degrees, clear. So like this we need to proceed to draw the frequency characteristics or the magnitude characteristic or phase angle characteristics, clear. So this is the procedure for same problems. You can proceed with the same procedure, clear. Thank you so much.